Hi, everyone, and welcome back to our dynamic programming series following Leetcode DP patterns study plan. So we have finished the very first two easy problems. Right now, we will start with the third one, which is extremely easy, straightforward. So this should be a walk in the park for most of you guys. But nonetheless, we will tackle them with seriosity. So the F3 Bonacci number. The Tribonaci sequence T of n is defined as follows. So we are given the first three elements, which is actually the first three elements of the Fibonacci sequence as well, 0, 1, 1. And then we are told that T of n plus 3 is equal to the previous three numbers for n is greater or equal to 0. All right. And given n, we should just return the value of T of n plus 3. Now, seems to be extremely straightforward because we have already tackled the Fibonacci sequence in the previous two videos, actually. I would highly recommend that you watch those two. This should be a walk in the park. Now, looking at the example, we have n equal to 4. And as you can see, we compute using the very first three given numbers, which will be our edge cases. All right, keep in mind that. The 1, 2, 3, 4 number, and then the fifth one. All right, and example 2, we have n equal 25, and I don't really want to calculate this. No, thank you. And we have certain constraints because I want to see exactly how much memory do I want to declare. Although, in case you are not coding in C++, you can just very easily. I'm trying to write general purpose code. I'm not trying to make any certain optimization, so you can write your code in Java, Python, whichever programming language you want. It's just about how you see these patterns and how to utilize them. Okay, so n is lower or equal than 37, and we are told that the answer is guaranteed to fit within a 32 integer. So the answer has to be lower than this value. Amazing. Now, coming back to our very beautiful whiteboard, which I didn't change from the previous problem. Now, much better. Right, so the Tribonaci sequence. So we have 0, 1, 1 given. And right now, when we want to compute the following one, we just have to add them together, and we get a beautiful 2. Now, as you can see, we don't need more than these 4 variables. We already know that we will only need 4 variables because right now we don't need the 0 any longer. We just need to update to look at these last 3 numbers, and if we want to compute the following one, we just add them together, and 1 plus 2 plus, 1 plus 1, 2 plus 2, 4. So we already have the fifth number, okay? So in terms of actual variables, we just switch the values like this, okay? And here we compute these values to get this one. Let's say something like this. Let's also make one more computation. So we have 1, 2, 4, and the answer right now, the sixth number should be 3 with 4, 7. And when we are thinking about moving the memory, the values between memory should be something like this. All right. Now, we are starting off definitely with our beautiful edge cases. So our beautiful edge cases are n should start from 0. So if n is 0, we have to return 0. That's the first one. If n is equal to 0, then we just return 0. Beautifully. Now, also, if n is 1 or 2, we cannot compute anything. We just have to return that value. So if n is 1, or n is equal to 2, we have to return 1. Now, in case this doesn't happen, and n is indeed at least equal or greater than 3, we have to make certain variables, and we have to, again, we can actually use the naming that the problem has actually given us and declare t0 equal to 0 and just copy paste these two lines. T1 is equal to 1 and T2 is also equal to 1. And we also need a solution variable, an additional variable which will play the role of the sum of these three. Now, we also have to make a loop in order to compute this as much as needed. So we declare an index starting from value 3. Why is that? Because we already have computed 3 elements. Okay. Index has to be lower or equal than n. Some of you may disagree, but I like writing the code in this way. It's much easier to understand, especially for beginners. And a space here. And what do we have to do here? Well, firstly, we are right here. So here is T0, here is T1, and here is T2, right? And we want to compute the solution. So first and foremost, we'll compute our beautiful solution like this. Solution is equal to T0 plus T1 plus T2. Nice. Now, as you can see here, for the following iteration, so this is going to be index is equal to 3. Now, for index equal to 4, this would be the new T0. This would be the new T1, and this will be the new T2. So as you can see, in order for us to not lose values, we have to start from T2. So T2 is initially equal to 1, and we have to make it equal to solution. And this will be actually the very first starting point. Let's take them one by one. Or actually, no, a solution is not the one that we're gonna lose. Is actually this 0 that we want to lose track of because we don't care anymore about it. So because T2 is coming this way, we are starting actually. We can start from left to right, no issue. So starting from T0, T0 has to go to 1, which is the value of T1. And we can write T0 equal to T1 like this. We'll make sure that we don't lose variables because T1 will take the value of T2 and T2 will take the value of solution. So it will go something like this. We move the value from T1 to T0 and we don't care about this one. Then we move the value from T2 to T1 and we don't care about this one because we take the value from solution and move to T2. And we don't care about this one because we will compute it in the next iteration. Actually, in this case, we could also have done it the other way around, although I think it's much easier this way. So T0 will take the value of T2, as we mentioned, T1 from T0 from T1, T1 from T2. So T1 takes the value of T2, and Tribonaci 2 takes the value of our beautiful solution. And then we restart the calculus and follow this pattern all the way up until we reached this nth computation. And we just return our beautiful solution. And if we didn't mess up anything, and we didn't, apparently seems correct. Let's also see what Leetcode's compiler says. And it says that it ran properly. Now, again, if you run it multiple times, you'll get different runtime and memory. Let me run just one more time to show you. So here we have 2 milliseconds. Actually, earlier I got 0 when I tested it out, but nonetheless, the result is the same. Let's also submit one more time. Oh, and right now we got the runtime 0 milliseconds and 100%. So again, it's something that I've mentioned in, I think, every single one of my videos. Don't take into account that much the runtime that the Leetcode gives you, especially when we are talking about easy problems. About problems where you just make a few calculations and that's it. If you were to have, let's say, matrix computations and searches and huge algorithms with very high time complexity, then you could have taken into account this runtime. But because it's a really simple case, focus on solving the problem and in quite an optimized way. And we'll talk about how to improve your code much better in the future. Thank you for watching. See you in the next episode. Bye.